Okay, so I am recording, y'all. I hate to tell you this, but I made a small mistake on two problems. So I'm going to fix that real quick. Okay, I'm really apologize. It's not a huge thing. It's going to be an easy fix. Let me show you something. So let's go right here. I don't know when I copied and pasted something, the writing kind of shifted around. But right here, when we did when we did this problem right here, this is where we did it, right? And we integrated. Okay, the only change that I need to make, y'all, everything else we did was perfectly fine. One small error. The error that I made, I'm supposed to divide by 1 minus, or 1 over 5 minus 1. I need to take the difference in my limit in the very beginning. That's the only mistake that I made here. So let me ask you a question. What is 1 over 5 minus 1? 1/4, right? Okay, so all I'm going to do now, y'all, is whatever answer that we came up with, which was 468, I need to multiply it by how much? By 0.25. Okay, that was a mistake I made, y'all. Sorry about that. So let me fix this here. So 468 divided by 4, 117. So my exact answer right here, y'all, is actually 117. Okay. So I'm always going to have this factor in the very front. Okay. And y'all, I made that mistake on two problems. I'm sorry about that. I made that on this one. The other one where I made it on was this one right here, y'all. When we found the average value of this one here, we did everything and we came up with this for my answer. So again, the first thing I'm going to do, I'm going to divide it by 1 over 4 minus 1. It's always divided by the difference in my limits. Okay. And the difference in those two limits there, 4 minus 1, is 3. So look, y'all, when we came up with our answer here, this was our exact answer. Aren't I now have to multiply it by 1/3? So now all I would have, y'all, is 2/3 e squared minus e to the 0.5. Okay. So I apologize about that, y'all. I just didn't want to let it go. And I don't know why it was. I was thinking about it as I was doing the problem, and for whatever reason, didn't fix it. 1/3, which is the same thing as dividing by 3, right? So when I originally had a 2 here, now I'm going to have a 2/3. So just to give you a little heads up, y'all, just so that you know when you're doing this right here, when we're finding the average value and we're integrating from a to b of f of x dx, the average value also has that little extra component right there in front, the 1 over b minus a. Okay, you're still integrating. Now you're just dividing by 1 over that difference in those values. Okay. So but anyway, I wanted to clear that up. Alrighty, so now let me go ahead and get started now on 5.3. Okay, so 5.3, y'all, is something called the fundamental theorem of calculus. And it's going to seem kind of silly, at least it does to me. I don't know, when I'm doing these problems. But look what it says. It says if f of x is continuous over the interval from a to b, then the function capital F of x is defined by f of x is equal to the integral from a to x of f of t dt, where f prime, or capital F prime of x, is equal to f of x. I'm going to ask you a question. Look at this symbol right here. When we have capital F prime, does that not mean the derivative of the big F? So the big F derivative is equal to F evaluated at that value right there. Okay. Look what it says. Note, f of x, capital F of x, is the antiderivative of f of x. So this is all you're doing in these problems, y'all. In all these problems, this part right here is going to give me the derivative when I evaluate it by plugging in that top limit of x. So f prime of x would just be x to the 4th. All I'm doing is I'm plugging in the x right here, and that's telling me what's the derivative. Okay, now think about that for a second. Think about this for a second, y'all. If I was integrating 2x, would you agree with me that the antiderivative would be x squared plus c? That would be the antiderivative of this indefinite integral right here. So wouldn't the derivative just be 2x? Right? And all I'm doing is I'm just taking that upper limit and plugging it in right there. Okay? Now, if that is my derivative, what is the derivative evaluated at -5? All I would do is plug in this number here, and we'd end up with 625. Okay? The fundamental theorem of calculus is just plugging in those derivatives. Yes, sir. The constant. Constant of integration. No, because remember, when you're doing this, remember they're not becoming constants anymore, because if you're integrating, if you integrated a constant, wouldn't you now have an x term? So it wouldn't be a third constant.
Okay, so but there can be like numbers like
But then it's still another constant, isn't it? Right? Yeah. Don't make it harder than it needs to be. It's not. So remember, think about it this way, John. So when the reason I wrote it like this is x squared plus c, because couldn't my f of x have been x squared plus 3? And if I took the derivative of this, wouldn't I still get a 2x? Right? Couldn't my f of x have been an x squared minus 7? And when I took the derivative of this, I still got a 2x? That's why we say plus c. In general, there's going to be some constant there, right? Even if the constant is 0, it's still there, right? There's still a number that you can have there. Okay, so take a look, y'all. Let's do the same thing here. I want you to look what we have. We have, if f of x is equal to the integral from 0 to x of t to the 3rd plus 3t squared plus 3 dt, it's asking me, can we find f double prime of x? Okay, before we find f double prime of x, y'all, we're going to find f prime of x. This easy way that we find f prime of x is we come back to this expression right here, and all we do is we plug in an x everywhere we have a t. That gives me an x to the 3rd, a 3x squared, and a plus 3. Okay. So I want to tell you something. If that is my first derivative, what would my second derivative look like? Uh-huh. Isn't it just 6x? Because we're taking the derivative, right? We're taking the derivative. Are we doing okay so far, y'all? All right, just checking with you guys. Okay, so look, let's try another one here. Now we have something called the fundamental theorem of calculus with the chain rule. So when I'm using the chain rule, y'all, all it says is just like we did before. We're going to plug in that upper limit into my function. The only part that's different is that now we're going to take the derivative of that upper limit. Okay? So look, if f of x is equal to the definite integral from x squared to 4 of t to the 5th dt, then f prime of x is going to be equal to, again, everywhere I have a t, I'm going to plug in an x squared in this case because that's my upper limit. Now that's still being raised to the 5th power, right? Now, the other thing I need to do, y'all, I need to take the derivative of my upper limit. What's the derivative of x squared? 2x. Okay. So now we can go ahead and figure this out. Anybody know what's x squared to the 5th? X to the 10th, very good. Times 2x, So x to the 10th times 2x would give us a, there you go. You got it. So y'all, the fundamental theorem of calculus, it's actually really straightforward because all you're doing is you're plugging in the upper limit into your function. Now, the only thing that you have to remember is if your upper limit, if it's something besides x, if it's x squared, if it's 2x, if it's 2x minus 5, then I still have to take the derivative of that upper limit. Okay, that's the only part that's really different. Okay. So let's come back over here. Okay, so now it says, sketch the region enclosed by y equals 3x and y equals 8x squared, and we're going to find the area of the region. Okay, so look, think about this, y'all. We want to find the area. Now, when we talked about this before, we found areas back in 5.1, we were doing those rectangles and stuff. We're not going to do any rectangles today. We're going to be able to do this using calculus. Okay. All right. So I'm going to try to draw a picture here. Let's see. I'm going to try to graph y equals 3x and y equals 8x squared. That's right. That's right. So we're going to try to figure it out. Okay, so we're going to go really, really slowly here, guys. Look, I'm going to go like this. I'm going to say that's 1, 2, 3, 4, 5, 6, 7, 8. Okay, I know that in this problem right here, y'all, here we go. See if I can put that a little bit better. When x is 1, y is 3. That's what 3x looks like. Let's see. Take a look at this one. When x is 1, y is 8. Now, the graph here, y'all, is probably going to do something like this. What I want to do is I want to find where those graphs overlap, okay? I want to find the point where these two graphs overlap right here. So the way I can find that, y'all, is I can set 8x squared equal to 3x, because I want to find the parts where they overlap. Okay, so the first thing I'm going to do, y'all, I'm going to move that 3x over. So I have 8x squared minus 3x equals 0. Okay. Can I factor anything out of both of them? Okay. We have 8x minus 3 equals 0. So look, y'all, we're going to have two parts. X equals 0. Well, look, they intersect right there, right? Then we're going to say 8x minus 3 equals 0. So 8x is equal to 3. So x is equal to 3/8. That's where they overlap right there. Okay. I want you to think about what we're trying to do. We're trying to sketch the region, or we're finding the area of that region where they overlap. So let me see if I can do it like this. Y'all agree this is the overlap? This portion right here? I want to mention something here, y'all. If I were to find the area for the red part, what I would be doing is I would be saying, look, I'm going to integrate from 0 to, what is the x value right here? 3/8, right? What is the top function? What's this line right here? Anybody know the graph of that line or the equation of that line? Y equals what? 3x, right? Okay. Now, if I wanted to find the area of the green portion, which would be this portion right here, we would integrate from 0 to 3/8 of 8x squared dx, right? Now, if I want to find the area of this part, you guys agree now that I got it subtracting? Because that would give me that area in the middle. Right, put a minus sign right there. So that's what we're going to do. Okay, first question, y'all. We're going to go really, really slowly here. What is the antiderivative of 3x. I'll give you a hint. It's going to have a 3. X to what power? 2 all over 2, right? Okay. I'm going to evaluate that from 0 to 3/8. Minus, let's come back over here. Anybody know what is the antiderivative of 8x squared? I'll give you a hint. It's going to have an 8. X to what power? To the third over 3, again, from 0 to 3/8, right? Okay, so look, y'all, we're going to do this in pieces. I'm going to keep that constant on the outside. 3 halves, 3 over 3, but 3 over 2. And I'm going to evaluate x squared at 3/8. And I'm going to evaluate x squared at 0. I'm going to do the same thing over here. I'm going to keep that constant on the outside, 8/3. I'm going to evaluate x to the third at 3/8. And I'm going to evaluate x to the third at 0. Okay. So far, am I doing okay? All right, we're going to go really slow here. So look, that's still, okay. 3 over 8 squared, is that not 9 over 64? Right? 0 squared goes away. Minus 8/3. 3 to the third over 8 to the third is, I don't know. I'm actually going to leave it like this, y'all, and I'll tell you why. Isn't that one going to go away too? The 0 to the third? Okay. Let's see if we can do some simplifying here. Let's multiply straight across. 3 times 9? 27 over 64 times 2 should be 128. Now, y'all, I want to mention something here. Let me come back and do it like this. Since we were raising that part to the third, y'all agree that's a 3 to the third and an 8 to the third? And won't this 8 here cancel with one of those there? Now there's only 2 of them. And won't this 3 here cancel with one of those? And now there's only 2 of those. So what's 3 squared over 8 squared? 9 over 64. Okay. And can I multiply them both by 2 so I can get a common denominator here? And so that's going to leave me with 27 over 128 minus 18 over 128, which should be 9 over 128. What was wrong about it? Writing everything. But look what we're doing. You're taking fractions and you're raising them to powers, right? All right. So, y'all, I want you to look at the next couple of problems I have here. We're doing the fundamental theorem of calculus part 2. Okay, so one thing I want to emphasize here, y'all, about these problems compared to the ones we did before. I want you to notice the problems that we did before. So I'm going to scroll back to one of these earlier problems that we did. Let's see. Let me scroll back to something that was maybe like this first one here. Okay, so when we did this first problem right here, y'all, notice how my limits were written. Notice the top limit was the variable x, and my bottom limit was just some constant, right? Like in this case, it was 5. And remember how we found f prime of x? Didn't we just take that value of x and plug it in right here, and we came up with x to the fourth? And then we did the negative 5 to the fourth, which was the 625. Okay, so in order for me to use the fundamental theorem of calculus, y'all, my top limit needs to be the one that's going to have the variable part, and my bottom limit needs to be the one that has the constant. So if I scroll back to these problems that I have here now, I want you to notice something. What's different is my bottom limit now has the variable and my top limit has the constant. So the way we can actually fix this, y'all, we can put a negative in front. And now we can reverse those limits. So if I were now to evaluate this here, right, I'm looking for the derivative with respect to x. I'm looking for my f prime of x. All it's going to be is now a negative. Everywhere I have a t, I'm going to plug in the x, and that would just be a negative x to the second. Okay? So I can reverse my limits, but now my integral becomes negative. Okay? When I reverse my limits. All right? So look, let's do the same thing over here. First question in this problem. You all, do I need to reverse my limits here? No. Okay, so look, the first part that says, let's find f prime of x. So f prime of x, all we're going to do, y'all, is everywhere we have a t, we're going to plug in an x. So that's going to be e to the power x plus 1 minus 4x plus 5. Okay, there's my derivative. Now, for the second part, if we're going to find f prime at 3, aren't we just going to plug in a 3 everywhere we have an x? Okay, now, y'all, the directions here are telling me to do some rounding. So let me go ahead and round this. E to the 4th minus 7. E to the 4th plus 5. Okay. So now I have, guys, if I'm going to round this to the nearest hundredth, remember the hundredth means the second decimal place. Would I write 47.59 or would I write 47.60? There we go. So again, I'm just plugging in my values, right? I'm just plugging in my numbers in. All right. So let's take a look at this problem, y'all. Let me ask you a question. Do I need to reverse my limit? Yes, we got to reverse our limit, y'all, because the bottom limit is the one that has the variable. So remember, all this is going to be, y'all, negative now, right? The integral from 20 to x of t to the third dt. So the way I'm going to find my f prime of x, I'm just going to plug in that x right here, and that gives me a negative x to the third. Okay. So if my limits don't, the way I know I have to reverse my limits is because the top limit needs to be the variable part, and the bottom limit needs to be the constant part. Okay. Okay, so Brittany, you were asking, are we going to be done by 2? We're actually done by 1:30. Yeah. You guys. So 5, what was that? 5.2 and 5.3, y'all. Not too long sections. They're kind of short. I guess last week when I wanted to start covering a little bit of 5.2, we probably could have waited for today because it didn't really take that long. But we will stop there, and then we will pick up on the rest of it, y'all, on, let's see, let me stop recording real quick. And y'all, there will be 2 videos I'll send out. But guys, one thing I want to mention. Okay, so let's see. If you notice, I also have this here, y'all. So I have some information about all this business. Let me see. I got to make sure I'm putting here. This needs to be a homework, and I don't know if it's setting it up as a homework. Needs to be a percentage. And it seems to be the homework. There we go. There we go. That's better. Okay. So let's see. Review for test 2 and test 2 instructions. Okay. So y'all, let's see. Formula sheet for test 2. I got that right here. If you click on it, it's the formula sheet for test 2. Again, all I did, y'all, is really go through the notes for chapters 4 and 5 and kind of copy and highlight these kind of, sort of like instructions or directions or whatever else you want to call it for, integrals and that kind of good stuff, right? Let's see. Let's see. Test 1 opens up Wednesday, April 20th. That is not this Wednesday. That is next Wednesday. So guys, what we're going to do, I'll put it in here too because I forgot to put it in here, but next Wednesday. So let me edit this real quick. Let's see. Here we go. Okay. So Wednesday, April 20th, we will see. Okay. So next Wednesday, you guys, what we're going to do in class is we're going to review. Okay. I've already set up the review. It's there. So let me just do this real quick. I'm going to type those. There we go. Okay. So y'all, we're going to finish up chapter 5 on Wednesday. Okay. Next Monday, I am going to introduce chapter 6. I haven't decided how much we're going to do yet, but we're going to do some stuff in chapter 6 on Monday. Next Wednesday in class, guys, what we're going to do is we're going to answer questions from the review. So just like the way we did for test 1, right? If I come back over here and I click on this, I think it's going to let you open it up already. Yeah, it's already open, right? So the review is already open, y'all. It's there. It's got 40 questions on it. What we're going to do next week, y'all, I will answer any questions you guys have out of the review. Okay, so next Wednesday, all we're going to do, come in, which ones do you want to know? Just like we remember the last time I printed out the review and I said, okay, which ones do you want me to go over? We'll go over them then. Then the test, y'all, the test will open up that Wednesday, which is not this coming Wednesday, but the next Wednesday. It'll open up at 2:50 at the time class starts, has 20 questions. Guys, those questions came directly from the review. Okay, so again, 40 questions in the review, 20 on the test. Those 20 questions came directly from the 40. Okay, the 40 questions from the review, y'all, came directly from our homework from chapters 4 and 5. So there's not going to be anything on the review or the test that we haven't actually seen. Okay, it'll all be stuff that we've already seen before. Guys, you get 2 attempts, right? Remember, when we did the first test, was there a time limit? No, right? No time limit here either. Okay, you just got to get it done by the due date, which is the 27th. Okay, so just make sure you get it done by then. You can use the calculator, you can use the notes, you can use the formula sheet, all that kind of stuff. Okay, so again, just a heads up, y'all. Next week on Monday, I will cover something new, but then Wednesday, we will start, all we'll do is review that day. Does that make sense? Okay, so this week, y'all, all we have to do on Wednesday is 5.5. That's all we got, okay? So, there we go. So anyway, just wanted to give you a heads up on that stuff, y'all. 5.2, y'all, you can find the homework for 5.2 over here. Let's see. Yo, the quiz for chapter 4 is due by Wednesday night, okay? I didn't make a quiz for chapter 5. We'll probably take another quiz maybe on chapter 6 or something like that. We'll just have 4 quizzes throughout the semester, I think this is quiz number 3, right? Yeah, quiz number 3. We'll probably just take one on chapter 6. We won't do one on chapter 5, unless you guys want one on chapter 5. I don't know. It's up to you. I mean, I don't know. The only reason I said over chapter 5 is then we won't have one on 6, but I don't know. It's up to you guys. But anyway, does that make sense on what we're doing for the next couple of days, though? Okay, so anywho, just wanted to give you a heads up on that stuff there, y'all. Again, the review is already open, y'all, so if you want to start working on it, you're more than welcome to. If you want to do it in pieces, I would definitely do it in pieces. I wouldn't sit down and do 40 questions in one setting, but I would try to get it done. Y'all, the reason why I have the review open now is so that next Wednesday you can say, okay, sir, I don't know how to do this one, I don't know how to do this one, I don't do this one. I really don't want to go through like, okay, can we try this one? Can we try that one? Yeah, we can try them all, right? But I want to make sure that we do the ones that we really need help on, right? So that's why it's really open. Alrighty, anywho guys, that's it for us today. Thank y'all for showing up, I appreciate it, and, y'all got questions, let me know. Those of you who are watching from home,